Hello class, this is your 7.0 review for quiz. So starting with the page that says simplify the following, I'm going to just run right through these problems, get you some solutions, and you can stop and rewind and go back as needed. So first one, we have some subtraction here. So remember, anytime you have subtraction here in the middle, we keep the first set of parentheses, we change this to addition, and then we change the sign of everything on this in the second set of parentheses. So change my 6a squared to negative 6a squared, the negative 2a to positive 2a, and the negative 3 to positive 3. I like to rewrite, so 3a squared minus 11a plus 4 plus negative 6a squared plus 2a plus 3. And of course you don't need this plus the negative there, but that's just the way it came out. So looking for like terms, 3a squared negative 6a squared makes negative 3a squared. Negative 11a and positive 2a makes negative 9a. And positive 4 and positive 3 make positive 7. So there's number 1. Number 2, Number 2 is 4x to the third plus 7x squared minus x plus 3 plus 3x squared plus 7x minus 2. So when we have addition now, I don't have to worry about changing anything anywhere. So I'm just going to copy this again without the parentheses. Not something you have to do, but something that makes it a little bit easier for me, especially when we're doing the subtraction. And now I look for my like terms. So 4x to the third, there is no any other x to the third, so 4x to the third stays. 7x squared and 3x squared make 10x squared. Negative, remember there's a 1 here, so negative 1x squared and, negative 1x and 7x make positive 6x, and then positive 3 and a negative 2 make a positive 1. And there's number 2. Here we go again, making these boxes when I want to write a number. Okay, number 3. We have 3x plus 2 squared. Remember, this does not mean that we give the squared to both of these. This is wrong. Okay, do not do that. The squared means that I have two sets of the same parenthesis. I have 3x plus 2 times 3x plus 2. And then either you distributive property FOIL this, or you use your area model, depending on whichever one you're comfortable with. So if we're distributive property or FOILing, we have 3x times 3x, which is 9x squared, 3x times 2, which is 6x, 2 times 3x, which is also 6x, and 2 times 2, which is 4. So combining our like terms, we get 9x squared plus 12x plus 4. If you're using the area model, then we set this up with our length that was a little funky. Our length being 3x and 2, and our width being the same, 3x and 2. We fill in our areas. 3x and 3x make 9x squared, 3x times 2, 6x, 3x times 2, 6x, and 2 make 4. When we write out all these pieces from our box, we get this same thing, which in turn leads to the same solution. So of course we're going to get the same answer. How you go about it, completely up to you and what you're more comfortable with at this point. Number 4, 4x minus 7 and 4x plus 7. So here, again, we can FOIL. 4x and 4x make 16x squared. 4x times positive 7 is a positive 28x. Negative 7 times 4x is negative 28x, and negative 7 times 7 is negative 49. Combining our like terms here actually makes them cancel because we have the same number, one positive, one negative, and I'm left with 16x squared minus 49. This is actually a special property. It's called the difference of two squares. And difference comes from the fact that we have subtraction. And squares, meaning 16 is a perfect square and 49 is a perfect square. And x squared, of course, is a perfect square. So I could have done this by just doing the first and the last terms, knowing that because I have the same exact terms, 4x and 4x, and the 7 and the 7, one being negative, one being positive, that my middle terms would always cancel. So if you recognize that, you can just multiply your first two terms and your last two terms because your middle terms will always cancel out. If you don't recognize it, you simply multiply it out and you get the same solution anyway. But it helps in factoring. You'll see a problem like this on the other side. So 4x minus 7, 4x positive 7, same thing will happen. 4x and 4x, 16x squared. 4x negative 7, negative 28x. 4x and positive 7 is a positive 28x, and 7 and negative 7, negative 49. So here you see when we go to add our like terms, negative 28x and 28x, these guys will cancel, leaving me with just 16x squared minus 49. Okay. Number 5 has 3 binomials, so this one gets a little bit more involved. X minus 4 and 4x plus 7. So I'm going to start out with FOIL, the distributive property. Just going to start with the first two sets of parentheses here. I'm not going to worry about the last one yet. So I'm just going to look at x plus 3 times x minus 4. So x times x is x squared. X times negative 4 is negative 4x. 3 times x is positive 3x, and 3 times negative 4 is a negative 12. Combining like terms, I end up with x squared minus 1x minus 12. So there's that set of parentheses. So now my problem is a different problem that reads x squared minus 1x minus 12 times 4x plus 7. So I took these first set of parentheses, turned them into this, and now I'll multiply that by the third binomial from the original problem. This one I'm going to do area model just to illustrate both ways here. So area model, when I have 3 terms, right, I need 6 boxes instead of just the 4. So this will be x squared, negative 1x, and negative 12. And this will be 4x and 7. So 4x times x squared gives me 4x to the third power. Remember, we add our exponents. This has an exponent of 1. Here I get negative 4x squared. And on the end I get negative 48x. On the bottom, 7x squared, negative 7x, and all the way on the end, negative 84. And now we just add up our terms like we would if we only had 4 of them. So I'm going to erase over here so that I have a little bit more room. If you need to go back and see that again, rewind or pause, whatever you need to do. So here I have 4x to the third minus 4x squared. Actually, you know what? I'm going to combine my like terms while I'm going through this. Might as well. So 4x to the third, there's nothing to combine it with, so that one's done. Then I have 7x squared and negative 4x squared. So combining those together give me positive 3x squared. Those are done now. Negative 7x, negative 48x. We add those together, keep it negative. We get negative 55x. And then the negative 84, we don't have anything to combine that with, so negative 84. And then here is the solution for number 5. Okay, number 6, and then on to the other side. So number 6 says negative 2 times b minus 3 times 5b plus 1. So we start with this one just like we did in our class practice, and we distribute the number here, negative 2, just to the first set of parentheses. So this is negative 2b plus 6. and now I can FOIL or use the area model to multiply my last. So I'll use the area model. If you used FOIL, either way, we'll get the same solution. This will be 5b and 1. So negative 2b times 5b gives me negative 10b squared. 6 times 5b is 30b. Negative 2b times 1 is negative 2b. And 6 times 1 is 6. Adding these guys all together, negative 10b squared, 30b minus 2b is positive 28b, and then plus 6. And there we are for number 6. Okay, on to the back. So now into factoring. So I have to recognize whether we need to use Xbox factoring, or we're factoring out a greatest common factor and a greatest common variable. Maybe I can just pick two numbers that multiply to be the last and add to be the first, or add to be the middle. So, oh, here I go with the squares again. Oh, and now I'm just drawing all over. Okay, there we go. Third time's a charm. Okay, so number 1 on the back, we're factoring x squared minus 10x plus 24. Now you can use Xbox factoring for all of our factoring. Remember, it's simply a times c in the top and b in the bottom, and then two numbers that multiply to be whatever is a times c and add to be whatever b is. So if I fill this in here, a times c, since a is here, we have a, b, c. A times c is just whatever c is, 24. Negative 10 is our b. So I need two numbers that multiply to 24 and add to negative 10. Those numbers are negative 6 times negative 4. Negative and negative multiply to be positive, and they add to be that negative 10. So negative 6x, negative 4x. Because our coefficient of x squared is 1, my negative 6 and negative 4 are the solutions in my parentheses. I don't have to worry about drawing the x and taking out greatest common factor because that coefficient of a is 1. So the factored form of this problem is just x minus 6, x minus 4. And number 1 is done. On to number 2. There I go again. Ay. Number 2. This is x squared minus 34x minus 35. So here we go. A times c, so a is 1. 1 times negative 35 is negative 35. And b is negative 34. So two numbers that multiply to negative 35 and add to negative 34. That's going to have to be, let's see, multiply negative 35 and add to negative 34. It's going to have to be negative 35 times 1. That'll be negative 35, and if I add those guys, I definitely get negative 34. So negative 35x and 1x. And now that will give me straight away my solution. This can be factored, two separate parentheses, both starting with x. And I just take the numbers right from here. Again, we can do it this simply because a, the coefficient of x squared, is 1. So this is negative 35 and positive 1. And this is the solution for number 2. Now 3, 4, 5, and 3, 4, and 5 really, now is where we need to use the not only the x but also the box, because the coefficients in 3, 4, and 5 are bigger than 1. So number 3, I promise one of these times I'll stop doing that. Number 3 says 2x squared plus 5x plus 12. So again, here's my x. Start out a times c, 2 times 12, 24. B is 5. So while I'm thinking of things for that, draw the box over here. This is 2x squared. This is 12. And whatever I find for these lines over here will be what I put in these lines here. Okay, so let's see. 24, add to be 5. Multiply to 24, add to be 5. 6 and 4, that's 10. That's not going to work. 8 and 3, did I copy? Oh, see, here we go. Another case of copying the problem wrong. This, let me go back to my color, is not positive. This is negative, which means this is negative 24. Okay, now it should make some more sense. So we'll have to have 8 times negative 3. That will give me a negative 24. And when I add them together, I will definitely get 5. So there are my terms. 8x, negative 3x. So those two go right in this box here. 8x and 3x. And again, it doesn't matter which one goes where. Now I factor out greatest common factor. So greatest common factor between 8x and 12, I believe, should be 4. Greatest common factor of 2x squared and 3x. Well, the greatest thing that goes into 2 and 3 is just a 1. But x squared and x also have an x in common. So now up top, 1x times what is going to get me 2x squared? Well, that's 2x. And 1x times what is going to get me 3x? And that is a 3. And one thing I also forgot to change here in this box, this should also be a negative 12. So, I'm just a mess on this problem. This is a negative 3 because that came from here. Okay, so this 3 that I pulled out should be a negative 3. Okay, let's just make sure this works and move on to another problem because this one just seems to be messing with my head. So 2x times 1x is 2x squared. That checks. 1x times 3 is negative 3, or 1x times negative 3 is negative 3x. That checks. 4 times 2x is 8x, and 4 times negative 3 is negative 12. So this is one set of parentheses, this is my other, and I have it factored. So equals 2x minus 3 and 1x plus 4. And no, you don't need to write the 1. I just put it there just to show the factor. Whew, okay, hopefully the next one goes much more smoothly. So we have number 4, 6x squared plus 23x plus 7. And here's our x. 6 times 7, let me make sure I copied it right. Plus, yes, okay. 6 times 7, 42. 23 goes down here. So two numbers, multiply to be 42, add to be 23. Let's see. 42, how about 21 times 2? Because 6 and 7 are going to make 13, so I got to be higher than that. So 21 times 2, add them up, you get 23. There they are. So 21x and 2x. Okay, let me erase these guys, get that out of the way, and we will draw our box. Here we go. So 6x squared, here's the 7, here's what I fill in from these lines here, so 21x and 2x. And now let's factor it out. So greatest common factor of 21x and 7 would be 7. Greatest common factor of 6x squared and 2x would have a 2 and an x in common. So 2x times what is going to give me 6x squared? That's 3x. And 2 times what gives me 2x? That's just a 1. So let's check it with the bottom. 3x times 7 is definitely 21x, and 7 times 1 is definitely 7. So the solution for number 4 is 2x plus 7 times 3x plus 1. And there's our answer for number 4. On to number 5. I think I made it one problem without doing that. On to number 5. 2x squared plus 20x plus 50. Okay, for our x, 2 times 50 is 100, and the 20 goes here. Multiplying to be 100, adding to be 20. That one's a fairly simple one. It's 10 and 10. So 10x and 10x. 10 times 10 is 100. 10 plus 10 is 20. So drawing the box, here's 2x squared, here's 50, here's 10x, and here's 10x. Factoring out, common factor, 10x and 50, both divisible by 10. 2x squared, 10x, 2 is the biggest number, and x is the variable. So 2x times x is going to give me 2x squared, and 2x times 5 will give me 10x. So to check, 10 times x is 10x, 10 times 5 is 50, and here's the solution. We have 2x plus 10 times x plus 5. There is our factored form for number 5. Number 6. So number 6 is that difference of perfect squares problem that I was talking about when we were talking about the other side. So I have 9x squared minus 64. So you can think of this, if we rewrite it, you can think of this as 9x squared plus 0x minus 64. So those two middle terms, like in the problem on the other page, they canceled out and left me with 0 x's. So when I go to factor this, I recognize, which will make your life way easier, that 9 is a perfect square, 64 is a perfect square, and x squared, of course, is a perfect square. So all I need to do is find out which two numbers multiply to give me 9x squared, and which two numbers multiply to give me negative 64. So if I just go straight to this box model here, area model rather, 9x squared, the same exact thing, 3x and 3x, to make negative 64, 8 and 8, 8 times 8 is 64, make one of them negative. And now, of course, we want to check and make sure that what we've done actually works out. So if we fill in these other boxes, 8 times 3x is 24x, and negative 8 times 3x is negative 24x. And there's what I was talking about, where these two terms cancel to give you this 0x, which is why it's not written in the first place. So this factors to 3x plus 8 and 3x minus 8. Now I could have done the a times c and done the whole x, but 9 times 64 is going to give us a rather large number, and then we have to figure out what two numbers are going to add to give us 0. And I think that just recognizing the difference of perfect squares is much, much easier. Okay, so 7, 8, 9, and 10. Let's finish this guy off. So this is, we don't have they're not quadratics anymore. They're not just squareds. Okay, they are factoring out a greatest common factor. So in number 7, we have negative 10y to the 7th plus 6y to the 10th minus 4y to the 10th x minus 8y to the 8th x. Okay, so let me make sure I copy the problem right before I go through this whole thing and it's messed up. Negative 10y to the 7th, 6y to the 10th, negative 4y to the 10th x, negative 8y, okay, perfect. So, greatest common factor. 10, 6, 4, and 8. So 4 would be nice, but 4 doesn't go into 6 or 10. So it's going to have to drop down to a 2. So I know everything's going to be divided by 2. And now for greatest common variables. So, starting with the y. Y to the 7th, y to the 10th, y to the 10th, y to the 8th. So I can take out up to a y to the 7th. That's the greatest number that they all have in common, the greatest exponent that all the y's have in common. As for my x variables, let me put the y's in. y7, y7th, y to the 7th, and y to the 7th. As for my x variables, only my last two terms have x variables. My first two terms don't, so x is out of luck. It's staying right where it is. So we divide out. So I'm going to take my 2y to the 7th, put that out front, and now we divide. Negative 10 divided by 2, negative 5. Y to the 7th, y to the 7th, that cancels, leaving me with no y's in my first term inside the parentheses. plus. 6 divided by 2 is 3. Y to the 10th, y to the 7th, subtract, gives me y to the 3rd. Negative 4 divided by 2 is negative 2. Y to the 10th, y to the 7th, that again subtract, 10 minus 7 is 3, and the x remains there. Negative 8 divided by 2 is negative 4. Y to the 8th, y to the 7th, 8 minus 7 is 1, so I can put in the 1, or you don't have to, we get just the y, and then the x also stays there. And here's the solution to number 7. Okay, number 8. 12y minus 8. Okay, greatest common factor. I would love to be an 8, but it's not. It's a 4. And no common variable, because there's a y with the 12, but no variable with the 8. So I can only take out a 4. So if I go through and divide out this 4, 12 divided by 4 is 3. Got to keep the y. Negative 8 divided by 4 is negative 2. And my greatest common factor and variable come out front. Or they can be behind too, it doesn't matter. So we end up with 4 times 3y minus 2 for number 8. Number 9. 7w 5. These originally said minus. I hope I remembered to tell you to change them to plus. If I didn't, do it now. Whoops. Y plus 5. So now, again, because they're addition, whether it's 5 plus y or y plus 5, it doesn't matter. That's my greatest common factor. I can factor out the y plus 5. And because I'm factoring out a whole quantity, that whole quantity is just going to cancel. Whether I factor out y plus 5 or 5 plus y, doesn't matter. Addition is commutative. It works both ways. So when I factor that out, here I have y plus 5, and in my next set of parentheses, once this cancels, I'm left with just the 7w, and here I'm left with just the 9. And there's my solution to number 9. Last but not least, number 10, same idea, negative 5m plus 2 minus 4q 2 plus m. Again, factoring out that whole entire quantity, it's m plus 2, so divide out by m plus 2 and divide out by m plus 2. The m plus 2 is my first set of parentheses, and then I multiply that by, again, since this cancels, I'm left with just the negative 5, and this cancels, I'm left with a negative 4q. And there is number 10. So hopefully you did well and you were able to check your work. Come to class the next time I see you with any questions you have before we start the quiz, and I will answer them for you. All right, see you soon.